All right, we're going to talk about buffers. And remember, to have a buffer, you have to have two things. You have to have a weak acid and its conjugate base. Buffers work because you have two different kinds of soldiers. You have acid soldiers and you have base soldiers. So right now I've got these red over here and I've got 10 of them. They represent my acid soldiers. So in this example, it's going to be acetic acid. These over here represent my base soldiers. So this is going to represent the acetate from sodium acetate. So if I've got an equal number of my acid soldiers and my base soldiers, I know from the Henderson-Hasselbalch equation, my pH is going to be equal to my pKa, which is 4.76. Now, the first problem that you need to make asks you to make a buffer that's pH 3.9. It's much less than that. So that means I can't have an equal number of my acid and my base soldiers. I need to have an imbalance and an excess of my acid soldiers. Okay, because remember, there's two things that we need to think about from a buffer. We need to think about the ratio of our acid soldiers to our base soldiers. That tells us what the pH of that solution is going to be. And then the buffering capacity is going to be dependent upon sort of the total number of soldiers that we have. Okay, so that's pretty straightforward for the first problem. And what we're going to have is we have a two-component buffer. So you're going to figure out how I dilute acetic acid to give me this many acid soldiers. And then you'll figure out how much sodium acetate do I need to weigh out to give me this number of soldiers. Okay, the next problem is a pH 4.47 buffer. So it's going to have a few more acid or base soldiers because it's not as low of a pH. So I have a ratio that's closer to 4.76, but at 4.47, I still have an excess of acid soldiers compared to base soldiers. Now here again is where this problem is going to become a little bit different, because what's going to happen is I am not making this as a two-component buffer. I still need to know how many acid soldiers and how many base soldiers I need to have, but I'm going to start with my army completely as acid soldiers. So I've got 7 base soldiers here, but I'm not starting with those 7 base soldiers. I'm starting completely as an acid army. You'll notice I put 7 more of these in because I need to have the same concentration of acetate in. Because remember, the concentration of your buffer is a combination of your acid soldiers plus your base soldiers. But if I were to figure out the pH of this solution, it would be quite acidic. Again, I need to have some of these acid soldiers be made into base soldiers. So how do we do that? I have an soldier converter. In this case, this is potassium hydroxide. And what happens is when potassium hydroxide finds an acid soldier, it converts it into a base soldier. And so I'm going to have this happen now 7 times. I've got 6 more times, 6 more acid conversions to make them into base soldiers. And when I do that, you'll notice I still have the same number of soldiers. So the concentration of my buffer did not change. But what changed was the ratio of acid soldiers to base soldiers. Remember, what's going to be left over here after I do that chemistry is just going to be potassium from my potassium hydroxide. But now I've got the correct ratio of acid soldiers to base soldiers to make the correct pH of that buffer. And that's how this is going to be different. Now, we had to do a lot of chemistry here, and you're going to do that calculation and figure out this is quite a large volume of potassium hydroxide you're going to use. So you want to pre-calculate that so you're not sitting there at the pH meter dripping that in and being there forever when you had a large amount you could add initially.